Hello, everyone. Let me shortly introduce myself. I am Evangelia. I have been bootstrapping since a couple of months my own company, and I have been mostly working my entire career as a front-end software engineer until recently in Elastic for 10 years in Zurich in Switzerland, developing web apps, mobile apps, and before that I was in London for a couple of years on a different area in semantic web. All right. What's the goal of this talk is to understand how data flow and reside in the browser. And once we understand that, we will understand the different ways we have nowadays in the React ecosystem, how to update the state. If we understand how to do this properly, we will prevent future headaches, bugs, we can improve the performance of our applications. Firstly, on the next diagram, we will see in a framework agnostic way how data flow in a web application before we go and compare the different React state managers in the next part of the presentation. So as we can see, the data are being retrieved from the database. Sorry for the slides. I see they are a bit misplaced here anyway. The data are retrieved from the database. They hit the proxy layer for future retrieval, and once the data are hitting the browser, I visualize this brick wall that you can see, which actually, before we actually, the moment we receive the data from the backend and before we render them as pixels on the screen, there are some standard processes that are taking place in every web application. One of them is the data transformation. Data transformation, it's not working, that's fine. The links are not working. Sorry for that. Data transformation is the phase during which we don't directly render on the screen what we see from the backend. Sometimes we need to modify slightly the data. When does this happen? When we need to uppercase the text, lowercase the text. Often we retrieve the IDs as a string and we need in frontend to convert them as numbers. Sometimes we need to do some normalization in our data. So these are some examples of how we can transform our data. Once the data has been transformed, we need to bind them. Data binding is one of the core concepts in web applications, in which we bind JavaScript values to UI elements. That means that we, in HTML template-like syntax that we know in React, we bind the dynamic values in between HTML markup. This is the data binding phase, which is a declarative way how we bind data. Declarative is because we show in the code what is the construct, the final template we want to render. In previous decade, we used to use an imperative way of rendering data. Imperative is we were writing explicitly code instructions on how the data, how we can build an HTML element, and then what to add on it. While now everything is way more clear and more componentized. Data rendering, that's the third sub-process that I'm explaining now, is the phase during which we convert the code that we just described, this HTML-like syntax, into actual screens on the picture, on the browser. The data rendering is a complex phase under the hood, behind the scenes. On our daily work, we don't need to do much on that, but under the hood, we need the template phase, the layout phase, the painting phase. These are how the parsers are parsing the HTML and convert them into DOM nodes, CSM nodes, and so forth. Once we do all these sub-processes, we hit the browser. And there are three states that our data can end up in our browser. Either they can be successfully rendered in the page, as you can see the rendered data. If they are heavy enough or if there is a network issues connectivity, they might take a while to load, and that's why we have the loading states. And the worst case scenario, we have an error state. Data for any reason, any bug in the front end, back end, network, whatever, security issues, we couldn't load the data. Why I'm saying those three states? That in front-end logic, we need to take into consideration all these three states and implement them. Because if we don't implement the loading states, for example, the loading states is the states during which we are still wait until we finally receive the data. If we don't implement a rotation icon, for example, the user might believe that the system has been crashed, has frozen. So it's important to always notify the user to what is happening. All right. As you can see, I have used the word concurrency. With concurrency, what is meant is we can execute multiple operations at the same time in a web application. We can ask for different API endpoints to receive data. The user, in the meantime, will start interacting with the screen. So there are lots of things that are going on. So this is what's happening when the data are received on the browser. On the next slide, we will see how what happens on the data from a very abstract, high-level perspective after we start interacting as users in the screen. After we start clicking buttons, what is happening at a high level? Let's assume we click on this delete icon, the red delete icon that I have on the fourth item here. You can see my cursor. Before I make this action, let's first take a screenshot on this page. This screenshot contains the state of the system in this exact moment in time. The state of the system in this moment in time is the list of data that it has for every feature and component. So when we start interacting with the interface, and by removing this button, we are actually changing something on the state. We are telling to the state, we are instructing to the state, hey, I want to remove this item. How this is being removed, we will see later on the different examples. But for sure, we are changing something. We are removing this item from the state. And then we want this change to be reflected back to our screen, the element to be completely removed. So this process of updating, letting the component know, hey, I changed, you need to change yourself as well, is like the reactivity concept. So we have the update concept, which is the moment that we modify, we first execute the action, and then is the reactivity, that is the notification on the UI elements when the change state changed. Another notion here is that the predictability, it's not very clearly written, but I hope you understand, is the second orange thingy, predictability. So let's assume that the item that you can see on the first screen is being reused on the second screen, on the statistics page. And the moment that we removed the item from the first page, when we land on the second page, we're expecting that this item, this thumbnail, to have been removed from there as well. So actually, we want to be able to predict how our system behaves on other parts of the architecture when we perform an action. So that's why we need to make sure that we properly make all these updates in order to predict what will happen on other parts of the application where the same component is reused. A last concept that I want to show is the consistency. You can see that we have a last name. That's a very common data in every application. And this is used across almost every screen. We need to make sure that this type of information, which is shared across many places, is being consistently retrieved. It's not retrieved every time we go to the second page. We want somewhere in one place to have this information to make sure we access it from there. So on this screen, I wanted to demonstrate what are the potential problems that might happen if we don't properly update the state. For example, you can imagine a shopping cart where we are adding new items on a shopping cart. If the state management is not properly working, we might have a wrong number of the pending items on the system, and we might believe that something is available to buy it while it might not be. So this is an example of why all these numbers on data really matter. I'm summarizing on the next screen what are the problems that actually are solved by global states. The main goal of this presentation is global state managers in React applications. I take as prerequisite that you're familiar with the concept of global state versus local component states, because the state managers are introduced to really handle the cross communication across components and on large-scale applications. For local level, it's easy, but the challenges that have been popping up are cross components for large-scale applications. So we resolve predictability issues, performance issues in order to prevent extra re-renderings. We don't need to make extra HTTP requests if some data are cached in the browser. We resolve the issue of consistency that I mentioned before, concurrency issues. We cache data temporarily on the browser in frontend in order not to re-ask them from the backend if these data are not updated regularly and they are fixed. All right. When do we really need a global state? Because this is a very common question and it's a very controversial discussion. Only in complex applications with shared data. It's not a good practice to put everything in a global object in JavaScript, in a global state, only when it's needed. When it's needed, when it's shared. Examples of shared data are the user authentication information like username, search query results. In quite a lot of applications, we have a list of items of data which are being shared across different pages. So we don't want to repeat asking this list of items again and again, unless they change in the future, and we need every now and then to sync them. Theme settings, multiple steps form data. Some forms have multiple steps, and we can store in the browser the selections that the user has made on the previous steps if we need to go back and forth in the form. These are examples on when we would need a global state. Also, we would need global state when we have very deeply nested components. The markup has become crazy. We all know how complicated it can be done. Not complicated, but super nested. And when we have very many different levels, it's not ideal to do props drilling. The props drilling is how we start learning and doing state management, but it's not a very efficient way to do props drilling because it also complicates our test. It's not very maintainable. If we need to make a change, we need to make it through all the components from grandparent down to the grandchild component. So that's why if we have very deeply nested components, we use global state so that each one of these components directly talk to the state. Message broadcasting and event-driven. What do I mean with that? The core of frontend is event-driven communication. We broadcast all the time events when something has been clicked, when something has been received. For example, often we need to send data from a modal that we have open to another header, to another part of the application. In that case, it's a very good scenario where we would need a global state that it will act as a third place where we can share the information to go from the pop-up to another header. Sometimes we have complicated calculations, and it is nice to be shared somewhere if they are frequently computed. So these are examples on when do we need a global state. All right, so in a nutshell, if I could summarize here in a very plain words, what is state management? Is how do we handle the transition from one state to the other. So the state management is the transitions from the first screen to the second screen. How we remove this row? Yes, the removal of this row is not done in the same way across the different React state managers. In MobX, in React Redux, in Recoil, it's done in completely different ways. But the final result is the same. We change the state somehow. Let's see how we can do that. Here I have grouped, I don't know how I can remove my name. Anyway, I can see the third one. Here we can see 6 categories of different mental models based on which each React state manager has been built. Let's go into one by one. Unidirectional mental model. In this one, in these state managers, the data flow towards only one direction. This is from a global store object down to the components. So when we render data, when we want to update them, in every case, the information goes always unidirectional. In reactive, in the second case, in the second category, in reactive mental models, the information goes bidirectional, and it's very, very automatic and more straightforward. Why? It's based on principles of reactive programming, in which when you make a change on a value, it instantly updates another value. We will see, MobX is a very good example here. The third one, atomic state managers, the data, the global shared data, are not stored in one object like in unidirectional case, but in smaller chunks of data, which are updatable and subscribable. These are called atoms in atomic state managers. Okay, state machines is not exactly a mental model, but a mathematical model. I was inspired by this one. I want to give you some food for thought how you could use state machines in your applications. It's mostly for local state, but with careful orchestration, it can be used also for global state as well. State machines is a concept in which we perceive the application from a behavior perspective. It's completely different, and we can write down upfront the potential scenarios in which the user can end up. So it takes more work upwards, but it's better long term. Cache-friendly solutions is state managers in which the data also flows unidirectional from one direction to the other, from local storage in this case to the components, and they are actually caching server-side data in the local storage, and they have a smart mechanism in which the data that are stored in the local storage keep syncing with the backend when the data gets stale in frontend, and then they keep updating the components. And we have React built-in solutions like the context API, which is used in cases where we have nested components and we don't want to use one of the other state managers, but we want to access shared data. So we are using context API. Let's go each one of them. In this graph, I'm visualizing also this grouping that I mentioned to you: reactive, React built-in, unidirectional, and in each category, examples of React state managers. Some of them are not only React, are used in Vue, in Angular, but it's a fast visualization so that you faster know when you hear a word, where does it fit. There is like a popping up all the time, new technology. So we need to understand the abstraction here. All right. In unidirectional, let's go to the unidirectional toolkit example. The ones that know Redux already, Redux toolkit is the most recent recommendation from Redux. And the only difference between Redux toolkit and Redux is that in Redux toolkit, you don't store the data in a CR global object, and you have separate actions files and separated users files. On the contrary, you groupify for a feature its data under a slice, and the slice contain aggregated the reducer, the action, and the data for that feature. And then all these slices are composing the store. For the ones that don't know Redux, let's go straight to the example. I have a counter and I want to increase the counter by one value. I click on the increment button in component A, and what is happening in Redux toolkit? I'm dispatching an action. Dispatching of an action is like I'm sending some orders, like a contract, a written contract, to an officer with instructions on what I want to do. So the dispatching of an action is not actually doing something yet, but it's contains in a written form what it promises to do, like increase something by X values. So the dispatching of an action is this written command, which is transferred to the reducer. The reducer is like another officer in the department, which is in charge of actually changing the value of the counter by 1. So the reducer actually changes the value. But before doing that, it makes a copy from the original value, because we don't mutate directly the data in the original object in Redux Toolkit. We make a copy of the original data, it mutates the value, and then once the counter has been increased by 1, there is the third officer. We call it, we can give a name like the updater, that notifies all the components that are using this value to re-render themselves. So this is how it reacts. I'm using on purpose this yellowish color so that to correlate this with the concepts we saw on the initial graphs, these abstracted notions of predictability, concurrency, updates that I show. This is now in practice. We see in every case where it's being used. All right, on the next screen, we can see a sample from the code of Redux Toolkit. On the left side, you can see how we can create the slice that contains the value of that feature and the reducers. And below my picture, there is a command where we are creating also the action. This is different from the old Redux. The Redux Toolkit, the action is generated via the structuring command, which is below my image. On the right part of the screen, you can see how we can inject the Redux Toolkit store into our component. Increment button, we use dispatch hook in order to have access to the dispatcher feature. And then when we click the button, we dispatch the increment action. As we saw before, the increment action is not doing yet anything, but when it goes to the store, the reducer will actually increase the value. And on the top, we have an example of the get case. Okay, let's move on to the second case. This is the bidirectional reactive case where the store does not contain the information in the form of a JavaScript object, but in form of observables. That's a very important difference between the two models. An observable is a sequence of events that are being emitted, is a sequence of values that are being emitted over time. So every row here is an observable, and every different color is a different value. And we map every row here with every field that we need to track in our application. For example, we want to track the value of the counter, we create an observable, is the first line. We want to track the temperature, is the second row. And over time, their values change depending on what action we implement on them. You can see we can have an action of increment, is the F1 example. F2 could be reduce the value. So how it actually works, when I click the increment button, in that case, I have firstly made this component as an observer. We will see on the code how it's done. And when I click the increment button, I'm instantly updating the value of this observable. I'm not dispatching any action as we saw before. I'm executing the command store.increment. And what it does, it goes to, let's assume the counter is the first row. It goes to the first row and it decrements the value by 1. And when it's updated, instantly it's being redirected back to the component, re-updated back to the component. It's pretty straightforward in implementation. On the left side, we can see how we can create the store in MobX. We implement the store as a class, and we use the makeOutObservable method from MobX, which is used to make all the fields we want to track as observables. Then we define the methods here. So this is the trackable observables, and these are the methods. And on the right part, we can see how we can inject it. Nothing is needed at the app level. Directly we go to the components. And for example, we want to increment the button. We just have access to the store and we click the increment action. When we want to read the value, the only thing we need to do is to import the observer from the MobX library and to wrap it around our component. And we can directly access the value as such. Let's go to the third case, which is the atomic state managers. In this case, the state is being stored in smaller chunks of information. which are called atoms, and the atoms contain a key always. Each atom has a key, which is like the variable name, the property name that we used to have in Redux. And the default is the actual value, the name, the property name, and the actual value. We have also, we can access the atoms directly from one component straight to the atom. More than one component can access the same atom. So atoms can be used both for local and global state. And we can have selectors. Selectors are more complicated atoms that compute values that are based on raw data. As you can see, except from key and default, they have also a get method that internally compute some values based on atom one values, for example. How we can use recoil within the components. We can use the use recoil value hook, for example, if we want to get the value, or we can use set recoil state if we want to set a new value. We can see this on the next slide. On the left side, you can see how we can create the atoms. Import atom from recoil atom, and we specify the key, the default value. The discount products atom is the selector, which has the key and the get. The get, for example, reads values from the other atom as we saw before. And on the right side, we can see how we can actually use it. I created a custom hook here, use products, in order to read the products from a fetch API. And okay, let's go here to the component where we can actually set, let's say we want to increase the counter. We go to the increment button component. We use the use recall state. It's similar to React set states, where we have both getter and setter. And we can use the set counter to increase the value of counter by 1. React-Query is another state manager, quite in demand and very much used lately. What it does differs from the others in the sense that in React-Query, the data are not stored in in-memory JS as we did with the other state managers. They are all JavaScript objects or observables, but still they are all stored in JavaScript runtime. But this one is stored in local storage. React Query is a smart fetching, caching, synchronizing, and updating mechanism. So I'm visualizing here the different caches that we have in our client in the browser. We have the client state. This is the JavaScript cache that we had on previously on Redux. We have a router, and we have more persistent layers like local storage, IndexedDB, which is databases on the browser, session storage, and we have the server state, which is the actual data coming from the backend. And usually in every frontend application, we have two types of data: the actual data coming from the backend, and the explicit data that we have specified on the fly in frontend, like what the user has clicked, like some really information that are not based on any API, but are explicit states that we specify ourselves. Okay, so how React Query actually works? React Query simplifies data fetching because when you use React Query, it loads the data from the backend, it stores them on the local storage, and when we use a component, we talk with the local storage. If this data got stale, became stale, and needs to be updated, the React Query has this smart mechanism to know when to make an extra call and to re-update itself. It has also functionalities of prefetching in some cases, which is quite handy and fast. So you can see some of the benefits of using React Query. Simplifies data fetching, improves reliability of server data by invalidating them. It has this smart invalidation logic. Performance optimizations, pagination and lazy loading. Request retries. So it's quite like it becomes like a black box to us. So we are mostly the consumers of it. And it's being implemented also similar logic in other frameworks as well. Let me go to state machines. State machines is a mathematical model but we can inspire from it on how we can orchestrate our states. I will go to this page, guys. State machine is a situation in which we perceive the system from the behavior perspective. So, and whatever if we click on a button, we want to know how it will behave. So we predefine what will happen if we click on the play button on this browser. We will navigate to the playing situation of the video. If we click pause, it will navigate to the pause state. How it differentiates from the traditional event-driven UI development. In traditional UI-driven development, we have the same state and different values on its properties. Here, we don't have the same state. We have different pages up front and correlations how we can navigate from one to the other. In this case, we can prevent edge cases. And it's a really nice way to communicate developers with product designers and managers because it has this visualization tool. So when you create the state machine and all the potential states, it really visualizes them. So what I would like to, these are really nice ChatGPT generated comparison tables where they compare the immutability, predictability among all this. I recommend you look into the slides. I have a few minutes left. And this is how I visualize the future of state managers. The future of state managers in frontend would be split it into sub state managers, and each one will be very good on doing something specific. For example, as we have the React-Query, which is very good on caching, we will explicitly have these sub modules of caching, which is React-Query. We will have server-side rendering often, and some components will be handled server-side. So we will explicitly have techniques how to do state on server-side rendering components. So we will have different sub-architectures within the state. It's not gonna be like always one state manager. It's sub-state managers orchestrated together. And in words, how I would verbalize this: future trends for state management move away from monolithic solutions like Redux to more atomic ones like Recoil and React-Query. Emphasis on composability and reusability. We saw that both in Redux toolkit we have the slices. Atomic are also smaller ones, so there is a tendency to split eventually again the state in smaller chunks, but they are just cross components shareable. Emphasis on developer experience, like the React query. It's quite handy for us, and it's also helpful for debugging. And all right, and server-side state management, what I mentioned before. Yeah, that's the future. That's how the future could look like for state management. Let me exit full screen. All right. Thank you very much. If you have any questions. Thank you. Yeah, the slides are not PowerPoint, are not Google Slides compatible, so I had on the fly to improvise. All good. Thank you, guys. Thank you very much.